Right at this very moment, out in the middle of the vast Pacific Ocean, something is quietly stirring that will help to decide whether farmers in Australia face a brutal drought, whether the coast of Peru is battered by catastrophic floods, whether the coming Atlantic hurricane season turns out calm or catastrophic, and even whether next year sets a brand new record as the hottest in all of human history. It is not a storm. It is not some dramatic thing that you could photograph from space. It is, quite simply, a shift in the temperature of a great stretch of ocean water, warmer or cooler than usual by just a couple of degrees. And yet that single, quiet, subtle shift acts like a great master switch for the weather of the entire planet. It is called El-Niño, and it has a cooler twin called La Niña. And together, the two of them may just be the single most powerful natural force shaping all of our weather that you have never once really understood. Before we go any further, if this is exactly the kind of story you came here for, take just 1 second to subscribe. A lot of folks watch these all the way to the end and simply forget to. And it genuinely helps this channel keep making them. Alright, let's begin. So what exactly are El-Niño and La Niña? Well, together, they are really the two opposite phases of a single natural climate pattern, one that scientists refer to rather grandly as the El-Niño-Southern Oscillation, or simply ENSO for short. And it is centered right in the tropical Pacific, which happens to be the single largest feature on the entire surface of our whole planet. Every few years, on an irregular sort of cycle of roughly 3 to 7 years, the surface waters across an absolutely enormous swath of that tropical Pacific either warm up or else cool down by somewhere between 1 and 3 degrees Celsius, compared to what is normal. Now that might not initially sound like very much at all, but because the Pacific Ocean is just so utterly, staggeringly enormous, that seemingly small change in temperature is more than enough to reach right out and completely reshuffle the weather across the entire world. In fact, it stands as the single most important driver of the natural swings in our global weather from any one year to the very next. To really understand how the whole thing actually works, let's start with the normal, everyday, ordinary state of the Pacific Ocean. Because blowing steadily right across the tropical Pacific, from the east toward the west, are great and constant belts of wind that we call the trade winds. And these winds effectively act like a giant, invisible hand, one that is constantly pushing the warm surface water of the ocean toward the west, piling it all up into a great, deep, warm pool over in the western Pacific, roughly around Indonesia and northern Australia. And of course, as all of that warm water keeps getting pushed off to the west, something else has to rise up and replace it back in the east, and so right along the coast of South America, cold water from the deep ocean comes welling up to the surface. So, in completely normal times, what you have is a warm and a wet and a rainy western Pacific and a cooler and a drier eastern Pacific, with that cold, upwelling water sitting off the coast of South America. Water which, by the way, happens to be absolutely rich in nutrients, and which feeds one of the single greatest fisheries anywhere on planet Earth. And I'm genuinely curious as we go, had you ever actually understood what El-Niño really was before today, beyond just hearing the name on the news? Let me know down in the comments. I read them all, and honestly, they often decide what I dig into next. Now, here is precisely where El-Niño itself comes into the picture. Because every so often, for reasons that are honestly still not perfectly well understood, those steady trade winds begin to weaken, or, in some cases, they can even reverse their direction entirely. And when they do exactly that, then that great pool of warm water, the one that had been piled up over in the west, comes sloshing its way back eastward, spreading out across the whole Pacific toward the Americas. The eastern Pacific warms up quite dramatically, and that cold upwelling of deep water off South America simply shuts down. And then, and this, right here, is the truly crucial part of the whole thing, the great zone of warm, rising air and heavy tropical rainfall, which normally sits parked over Indonesia, gets dragged eastward right along with all of that warm water, out into the central and the eastern Pacific. This entire state of affairs is what we call El-Niño. And it is that fundamental shift in where the planet's warm, rising air actually sits that then goes on to send powerful ripples spreading out right across the entire globe. And there is a genuinely elegant and slightly alarming twist to how an El Nino gets going, because once it begins, it tends to feed upon itself. Think about it for a moment. It is the trade winds that normally hold all that warm water piled up in the west, so when the winds weaken, the warm water slides eastward. But that warmer water in the central Pacific then weakens the trade winds even further, which allows still more warm water to slide east, which weakens the winds more again. The ocean and the atmosphere, in other words, egg each other on in a self-reinforcing loop. This is a big part of why a small initial nudge can snowball into a full-blown planet-shaping event over the course of a few months, and also why, once one is truly underway, it tends to lock in and persist for the better part of a year before it finally burns itself out and the system swings back. And La Niña, as you might now guess, is in essence simply the exact opposite of all this. It is what happens when those trade winds, instead of weakening at all, actually begin to blow even more strongly than they usually do. They pile the warm water up even further to the west than normal, and they pull even more of that cold, deep water up to the surface in the eastern Pacific, making it colder now than it usually would be. So La Niña is, in a certain sense, really a kind of supercharged, intensified version of the normal state of things. So, all told, you have three distinct modes that the planet can be in: the neutral, normal, everyday state, then El Nino, the warm phase, and finally La Niña, the cool phase. And the weather of the entire planet slowly cycles back and forth between all three of them. And this is also a good moment to explain that rather odd second half of the name, the Southern Oscillation part. Because back in the early 20th century, a scientist named Gilbert Walker noticed a strange seesaw in the atmosphere. Whenever the air pressure was unusually high over the eastern Pacific, it was unusually low over the western Pacific, near Australia and Indonesia. And then, a while later, the whole thing would flip. He called this great atmospheric seesaw the Southern Oscillation, and for decades, no one quite knew what caused it. It was only much later that scientists finally realized the truth, that Walker's atmospheric seesaw up in the sky and the oceans warming and cooling down in the water were not two separate mysteries at all. They were two halves of a single, deeply linked, coupled system, the ocean and the atmosphere, locked together in one great dance. And that is exactly why we now join the two names together into El-Niño-Southern Oscillation. So how exactly does a mere change in the temperature of the tropical Pacific end up affecting the weather thousands upon thousands of miles away from it? Well, the answer lies in something that scientists call teleconnections, which are, essentially, long-distance atmospheric links. Because when an El Niño shifts that vast planet-driving engine of rising tropical air off to the east, it does not merely change the weather sitting directly over the Pacific itself. It actually reshapes the great rivers of wind that flow all the way around the entire planet, including, and this is crucial, the jet stream itself. And as that jet stream shifts and buckles in response, then so too does all of the weather that it carries along with it, right across the whole wide world. Quick one before we continue. If someone in your family or a friend would find this genuinely fascinating, please do send it their way. That word of mouth is honestly how a channel like this one grows. And if it's been worth your time so far, a quick like really does help the next person find it too. So, during a fairly typical El Niño, the various effects tend to ripple outward in a reasonably predictable sort of pattern. Indonesia and Australia, for their part, tend to swing hard toward drought, and along with that drought comes the very real risk of severe and devastating bushfires. Meanwhile, along the western coast of South America, countries like Peru and its neighbors can suddenly find themselves hit with torrential rains and catastrophic flooding. And in fact, it was exactly these dramatic floods that first led people to identify the whole phenomenon of El Niño in the first place. Parts of the southern United States tend to turn wetter than usual, while the Pacific Northwest of America tends to turn drier. The Atlantic hurricane season is very often suppressed and calmed down by stronger high-altitude winds that tear the storms apart, even as, at the same time, the Pacific tends to grow rather stormier. And, riding along on top of the long-term, underlying warming trend of the whole planet. An El Nino year also tends to nudge the entire globe's average temperature upward, which is the very reason that the hottest years on the record books so very often turn out to be El Nino years. And La Niña, broadly speaking, tends to flip a great deal of this right around the other way. It tends, instead, to bring drought to the southern United States, and much wetter conditions up to the Pacific Northwest, and over to Australia. And, quite crucially, it also tends to supercharge the Atlantic hurricane season by removing those very winds that would otherwise have torn the growing storms apart, which is precisely why the most active and dangerous Atlantic hurricane seasons so often arrive during La Niña years. Now, the name of the whole thing itself actually carries a lovely little piece of history within it, because it was Peruvian fishermen, several centuries ago now, who first began to notice that every few years, right around Christmas time, a strange warm current would mysteriously appear off of their coast, and that, whenever it did, all the fish would suddenly vanish away. And so they gave it a name. They called it El Niño, which is Spanish for the little boy, or the Christ child, in a direct reference to the Christmas season of its yearly arrival. And, quite naturally, they later came to call its cold and opposite twin La Niña, meaning, of course, the little girl. And those old fishermen were, in fact, noticing something with truly enormous consequences attached to it. Because when a powerful El Niño shuts down that cold, nutrient-rich upwelling of water off South America, then the vast schools of fish that all depend upon it either die off or else flee the area entirely, and one of the largest fisheries on the entire planet can very nearly collapse overnight, bringing severe economic pain along with it. But the impacts, of course, reach very far beyond simply fishing, because a truly powerful El Niño, or La Niña, can ripple its way right through global harvests, driving up the price of food all around the world. It can shift the very patterns of rainfall that go on to spread deadly diseases like malaria and dengue and cholera. And it can even trigger the mass bleaching and death of coral reefs during the very warmest of the years. So these are genuinely not small or local little wobbles in the weather. The truly great El Niños of 1982 and of 1997 and of 2015 each caused tens of billions of dollars in damage and reached out to affect the lives of ordinary people on every single inhabited continent on Earth. And if you reach further back into history, the fingerprints of El Niño turn out to be written across some of the darkest chapters of the human story. In the late 19th century, a series of exceptionally powerful El Niño events helped to trigger catastrophic droughts and failed monsoons across India and China and Brazil and parts of Africa, all at nearly the same time. The famines that followed were almost beyond comprehension. By some estimates, tens of millions of people starved to death across the tropical world in just a few devastating years. At the time, no one had any idea that a warm current in the distant Pacific was quietly connected to a failed harvest in India or a drought in northern China. They could not see the invisible thread that tied it all together. And in a very real sense, the modern science of El Niño is the story of humanity slowly learning to see that thread at last, and, in seeing it, gaining the power to prepare for its next arrival, rather than simply being blindsided by it. But here, now, is something that is genuinely, and rather unusually, hopeful about this entire story. Because, quite unlike so very much of the rest of our weather, El Niño and La Niña are, to a real and meaningful degree, actually predictable, and predictable months in advance. And the fundamental reason for this is simply that the ocean moves slowly. That great, deep pool of warm water genuinely takes its time to slosh its way across the width of the Pacific. And so, by watching the tropical Pacific extremely closely, using a whole network of floating ocean buoys and satellites up above, and drifting robotic sensors down in the water, scientists can very often actually see an El Niño, or a La Niña, just beginning to form, and can then forecast its likely effects upon the coming seasons, sometimes as much as half a year ahead of time. And this is a genuinely rare and a genuinely precious thing, because it means that a country which is facing a likely drought or perhaps a likely flood-heavy season can actually receive a warning with many months still left to prepare for it, time to carefully manage its water, and to ready its emergency services, and to plan out its harvests accordingly. In a whole world otherwise so full of chaotic and unpredictable weather, El Niño remains one of the very few things that offers us a real and a usable glimpse into the future. And, as it just so happens, all of this is playing out in the real world right now. Because, after a recent period of cooler, more La Niña-leaning conditions, the tropical Pacific has been steadily warming all throughout 2026, and a new El Niño has been building up, with some forecasters now watching very closely indeed to see whether it might yet grow into a particularly strong event over the coming season. Now, exactly how strong it ultimately becomes, and precisely how all of its many effects end up unfolding around the globe, still carries very real uncertainty along with it. But all around the world, the forecasters are already watching it, and are already beginning to prepare. Now, you might also, quite reasonably, find yourself wondering, is climate change affecting El Niño and La Niña at all? And here, I have to be completely honest with you, because the truthful answer is simply this: we genuinely are not entirely sure yet. Because ENSO is, at its heart, a natural and an ancient cycle. It has been oscillating away out there in the Pacific for many, many thousands of years, long before human beings ever began to change the climate at all. Some research does suggest that a warming world might perhaps make the strong El Niño or La Niña events more frequent or more intense, or that it might increase the size of the wild swings between them. But this genuinely remains very much an open question, and the various climate models do not all agree with one another on it. What is a good deal clearer, though, is the other direction of that relationship, that when a warm El Niño lands directly on top of the steadily rising baseline of global warming, then the two of them simply add together, and that is exactly what tends to push the global thermometer up to those record-breaking new highs, just as it did in several recent years. So let me end, as I always try to, with genuine honesty and with real balance. First, it is genuinely important to understand that the effects of El Niño and La Niña are only ever tendencies, and they are never, ever guarantees. Because an El Niño makes a wet winter in the southern United States more likely to happen, but it absolutely does not ever promise one. The atmosphere is a fiendishly complex thing, and other factors are always in play as well, which means that any given El Niño can, and sometimes does, entirely defy its own typical script. These are the odds being shifted, in other words, not the future being written in stone. Second, as we have already discussed, the exact interaction between ENSO and climate change genuinely does remain deeply uncertain. It is an active and an unsettled area of ongoing science, and honestly, anyone who confidently tells you that they know for absolute certain how global warming is going to reshape El Niño is simply getting well ahead of the actual evidence. And third, it is really worth remembering that El Niño and La Niña are not, in and of themselves, disasters at all. They are simply the natural rhythm, the ordinary heartbeat of our planet's climate, a rhythm that has always been with us. The real challenge, in the end, is not that they exist, but rather that so very many of the world's farms, and its cities, and its water supplies were all quietly built around a comfortable assumption of steady and predictable weather. And El Niño stands as a powerful reminder of just how very much our weather naturally swings, all on its own. But the deeper lesson of El Niño is a genuinely profound one, and it is fundamentally this: that the weather right outside your own window is connected, quietly and invisibly, to the entire rest of the planet. Because a shift of just a few degrees in a single patch of ocean on the far side of the world can go on to decide whether your own summer turns out wet or dry, whether the food in your shops gets more expensive, and whether a distant hurricane season roars into life or falls quiet. We so often tend to think of the weather as a purely local sort of thing, as simply whatever it is that happens to be going on right here and right now. But El Niño reveals the deeper truth of it, that we are, all of us together, actually living inside a single, vast, and deeply interconnected system, one in which a warm ocean current, appearing quietly off the distant coast of Peru, can reach all the way out across 10,000 miles of open ocean and air, and gently, but unmistakably, touch your own life. So the very next time that you happen to hear a weather forecaster mention, almost casually, and in passing, that an El Niño is now developing out in the Pacific, I want you to understand that they are actually telling you something genuinely important about the entire year that is still to come. They are telling you that the great switch has now been thrown, that the whole planet's weather is now tilting over into one of its two great modes, and that, from the wildfires of Australia to the floods of Peru to the quiet or the fury of the coming Atlantic hurricane season, the ripples have, in fact, already begun to spread outward. El Niño and La Niña are, in the very end, quite possibly the closest thing that our entire planet has to a heartbeat. A slow and a powerful and an utterly natural rhythm, pulsing once every few years across the single greatest ocean on all of Earth. And learning, at long last, how to actually read that ancient heartbeat is genuinely one of the single most remarkable things that we as a species have ever yet managed to do. Because for once, just for once, the weather is not taking us entirely by surprise. For once, we can actually see it coming.